Hello, Math 30-2, and welcome to your lesson on dividing rational expressions. So it's the division of rational expressions. Now, this isn't much different than what we did last class, multiplication. In fact, it is pretty much the same thing, except we have to add one step. So if we look back to right here in junior high, this is a junior high question, and we were dividing fractions, what did we do? Well, if I taught you, you would have learned leavey-samey, changey-wangey, uppy-downy. So we leave the first one the same, 7 out of 10. We change the sign. And then uppy goes down. So we have 14 over 3. Now, I would simplify this because 7 times 14 is a big number. And then 10 times 3 is 30, big number. But we can make them smaller, right? Because this is 70 and 28, which is 98. But let's make them smaller. So I could cancel out here a 2. So we're left with a 5 and a 7. Nothing else could cancel out. So 7 times 7 is 49. And then here we have 5 times 3 is 15. Hey, that's the same thing as 98 over 30, both divided by 2. But it's easier to multiply. Let's take a look at the second one. We have the same thing here. But before we do this, let's simplify. This is 6 over 5 divided by 9 over 10. A lot better. Now what I'm going to do is leavey-samey, changey-wangey, uppy-downy. So leavey-samey, so that's 6 over 5, changey-wangey, and then up equals down, 10 over 9. And can this be simplified? Hey, yeah, that cancels off. Now this is just a 2. This cancels off to a 2, and this is a 3, because we have factors there. So that's 4 divided by 3. Okay? All I did was break these down to factors. This is the same as 2 times 3. This is the same as 2 times 5. This is stuff you did a long time ago, right? Okay, here we go. Now it says, now we're done our warm-up, we're just going to review non-permissible values, which are important. So for this rational expression here, the rational expression, the non-permissible value is, looking at this guy here, the non-permissible value is b, right? B is always my non-permissible value. It's always the bottom because I can't divide by 0. Now this one here, the rational expression, the non-permissible value, again is d. Okay? It's always on the bottom. It's before we do anything. Because this here is saying something divided by 0. I can't have anything divided by 0. It just doesn't make sense. It's like you're dividing by a number that's not there. Why can't we divide by 0? Well, try. If you have 10 people, how do you make 0 groups of 10 people? There's automatically a group. It just doesn't make sense. All right. Now let's take a look at this next part. It says, the first step in this is to invert and make multiplication. This introduces another non-permissible value. So now if we look at it, we also can't have c as 0. Because b times 0 is going to be 0, and we're dividing by 0. So c must also not be 0. Because remember, we cannot divide by 0. Here we go. So state the non-permissible values for the following. All right? So first of all, we have this. So this cannot equal to 0 because we cannot divide by 0. So we have 2x subtract 5 cannot equal to 0. Okay, so then I have 2x cannot equal to 5, and then x cannot equal to 5 over 2. All right, there's one. This one right here, whoa, x cannot equal to 0. There's another one. Let's look at this one. But we could switch this around, because this is the same thing as saying x minus 3 all over 2x subtract 5 multiplied by x all over x plus 1. That can't be 0 as well, so we need one more. So let's make that one more. So we also have x plus 1 cannot equal to 0. So x cannot equal to negative 1. All right, let's try this next one here. Well, I have right here, we know 3a cannot equal to 0. So then a cannot equal to 0, right? Because divide both by 3. 0. Now let's take a look at this one. We also know a minus 2 cannot equal to 0. Well, a then cannot equal to 2, right? And this, well, there's no thing. But once we put into a multiplication sentence, right, because to solve we must put into a multiplication sentence, we have a subtract 6 all over 3a, and then we have a subtract 2, multiplied by 1 over, we have to flip it because this is actually imaginary, over 1. We're going to get a plus 3. Okay, now we have one more. So we also know that a plus 3 cannot equal to 0. Continue that, a cannot equal to negative 3. There we go. So those are our new non-permissible values. So I have 1, 2, 3. And here we have 1, 2, 3 as well. Those are my 3 non-permissible values. All right? Okay, let's take a look at example 2. Or example 3. It says, state the restrictions. So first we have to simplify, and then we're going to state the restrictions. So let's take a look at this first one. So should we state the restrictions or simplify first? Non-permissible values are most important. So let's put all non-permissible values. I have here, we have x cannot equal to 0 because of that guy. We also have x cannot equal to negative 3. It's already in factor form, so it's easy. X cannot equal to 2. And we have x cannot equal to, well, negative 3. That's already being used. Now, let's make it so we can solve it. So, leavey-samey, changey-wangey, uppy-downy. Okay, so x plus 1 all over x subtract 2 and multiply by x plus 3. Okay, and we multiply this by 2x plus 1 all over, oh, whoops, made my mistake already. I have a horrible eraser here, so we have to flip it. We change the sign, change it wangey, uppy downy. So x, and then we have x plus 3 all over 2x plus 1. Now, looking at this, I have one more restriction, x plus 1. So x can also not equal to negative 1. Because that can't be 0. Okay, now this is multiplying. Can we do this? I'm just going to put that dot so we know it's multiplying. Now, it's multiplying. So let's start canceling off, like what we did before. Okay, x plus 1 and x plus 1, goodbye. Plus 3, goodbye. What are we left with? An x on top. And here we have 2, and then x subtract 2. And that's it. And this is what my restrictions are. That's nice. Not that bad. Pretty easy. Let's take a look at B. Whoa, that looks messy, doesn't it? I don't like things written like that, so I'm going to change it. So I'm going to have 4x plus 12 all over 3x plus 12. And I'm going to put it like this, divided by, because it's really being divided by all of this. 3x squared plus 9x all over x plus 4 squared. Oh, that looks a lot better, doesn't it? All right. Now, let's find my non-permissible values. What can x not equal to? Well, here I look at this, I could solve for that, and I'm going to get 4. So I'm going to get negative 4 for this one. If you can't remember how to do that, go back to our very first few lessons, and you'll remember. Now right here, I have x cannot equal to, well, negative 4 again, I believe. Yeah, this is negative 4 again. Now, on top, okay, that's good. So now let's try and simplify this. 4x plus 12 all over 3x plus 12 divided by, and here we're going to have x plus 4 squared all over, and we have 3x squared plus 9. Now this 9x. Now this one here we might have to factor out a bit. Oh, we switched it, so this is multiplication now. So there's my dot for multiplication, okay, because I switched it. So now we have another restriction, but I have to discover what it is. And in order to do that, I must first factor. So let's continue this out. I'm going to factor everything. So we have 4x plus 3, because I divided everything by 4. And here we have 3x plus 4 multiplied by x plus 4. And all of that is squared, so there's 2 of them. I'm going to just expand it. X plus 4 all over. Here, I can take out a 3x out of both of these. So 3x, I'm going to be left with x plus 3. All right. So now, looking at that, I also know x cannot equal to 0. What else? X cannot equal to negative 3. Okay, now let's see what can cancel off here. I have an x plus 3, x plus 3. X plus 4, x plus 4. That's it. So, what am I going to be left with? On the bottom, we have this times this, which is 9x. On the top, we have this multiplied by this, which is 4x plus 4. And these here are my restrictions of what x cannot equal. All right, did we get that? All right, last set of questions. It says, Write two rational expressions whose product is x plus 1 divided by 5x. So we want a product of that. We want a product that gives us that. Okay, but x cannot equal to 0 and 3. Well, I'm going to leave this at 5x. And we know another one, we want a product of it, could be x, I don't know, plus 3? Or it's negative 3, minus 3. Okay? So if I look at that, we want a product of it. So there's that there. Now, this must cancel off with something. So I'm going to put x plus 3 there. Okay? I'm even going to put a 2 and a 2 just to be fun and fancy. You can put anything you want there. Now the other one here, we need something here. But that's x plus 1. So I'm going to have x plus 1. And that's it. That's all we have to do. Let's take a look at the next one. Here's the quotient. Now, let's find an expression where the quotient is this. When we divide it, it is that. So first, I'm going to do the same thing, have this product. Okay? So I'm going to leave it because we have the product. So that is 2. And I'm going to have the same thing, x plus 3 all over 5x. And then we're going to have multiplied by x plus 1 all over 2x minus 3. Now this is a product. How do I make this into a quotient? I'm going to flip it, right? Because that's what division is. We flip this. So we have to work it wavy, samey, changey, wangey, uppy, downy. So we have 2x plus 3 all over 5x and divided by, now we have to flip this, x plus 1, and then we have 2x subtract 3. And if we look at that, yeah, it's the same thing. We go this to that, and it cancels. Now the reason why I did this is because I knew these were my restricted values. So one restricted value is there, and I have to leave that 5x. The other one I knew was minus 3. So I knew x could not equal to 3, right? So what did I do was I subtracted 3 from both sides. So x minus 3 could not equal to 0. That's how I knew one of my restrictions were there. So I put that in the other one for the product, which gives me that. So we have the x not equal 0, and then I use this other one to find that. Okay? But here it said another one is 2. So that's a little bit more difficult, isn't it? So now we have to look at that 2. So I'm going to add something here. I'm going to put an x minus 2, and then here I'm going to put an x minus 2. Because now, if I flip this is going to have still x minus 2, and this will here have an x minus 2. I missed that extra one there. So I put that in, and look what happens. So when I go from here to here, I flip it, and these will cancel off. Hopefully you understand that. If you have any questions on this, ask me again tomorrow, and I'll repeat it and help you with it. Okay? So good luck as I see you tomorrow, and we work on these questions together.